All right, last topic of the semester for us. Inferences for two sample means. We've done two sample proportions, now we're looking at two sample means. It's essentially the same as doing proportions. We're going to be using a different standard error formula, which it's written right here for you. And one good thing about this, we can use this for confidence intervals or hypothesis testing. When we did proportions, we had two different standard error formulas, one for confidence and one for hypothesis. Now we just have the one. Again, the confidence interval is x1 bar minus x2 bar, plus or minus the margin of error. Hypothesis testing, we're going to calculate a t based on the difference in proportions divided by standard error. And again, standard error is the same for both of those. Degrees of freedom, well, we're going to use the smaller sample size to find the degrees of freedom. So whichever smaller sample size, then we're going to use 1 minus that for our degrees of freedom to calculate. So they want to know if there's a difference in spending between men and women for Cyber Monday. The statistics are given here. The men spent $345 with a standard deviation of 40. Women spent $397, standard deviation of 51. And we had 50 of each, so both sample sizes were 50. Okay, so calculate the point estimate for the difference. Well, the point estimate is x bar 1 minus x bar 2. Sometimes I would like to make sure I get them straight, so I did x bar m and x bar f for males and females. The point estimate is males minus females, which is negative 52. That's perfectly fine to get a negative for your point estimate. If you'd listed females first, it would have been positive. It will not affect the outcome, the result that you get from this. Calculate the standard error. I gave you the formula back on the other slide, and there's the standard error formula. So for a 90% confidence interval, we don't know what the multiplier would be because we're using t's in the case of using means. So we do inverse t, 0.95. 49 is our degrees of freedom, and we get a t star 1.6766. We get a margin of error 15.3681. We add and subtract that from our point estimate, and we get negative 6737 and negative 3663. We always have to interpret an interval. It says we are 90% confident that the true difference in average spending between males and females is between those two numbers. And based on that interval, would there be evidence for the alternative that they're not equal if we did a hypothesis test? Well, when we're doing two means or two proportions, either one big thing we're looking for with the confidence interval is 0 in the interval. In this case, it is not. Both the values are negative. That indicates there is a difference between males and females. Since they're both negative, and the way we started with our point estimate, that indicates that the females spend more than males. So there would be evidence that the alternative hypothesis is true. All right, a couple more examples. Data on selling prices of homes. We want to know if there is a difference in these. So that would be a not equal. And because we're talking about two samples, we have Northeast and other areas, we have mu equals or mu not equals. And I did N and O for Northeast and in other areas in this case. Our standard error formula, there it is, the same one that we've used for other things. And we calculate a t, which is the difference in those two, divided by our standard error. We get negative 19636. So because we're looking for a not equal here, then that means we put a 2 there. And so we go to the negative side because that's negative. And we get this number, 0.0569. So the interpretation of that would be, or the p-value would be, if the home prices are the same for these two areas, this is the probability of getting the results we did, or even more extreme. So that p-value is between 0.05 and 0.1. That gives us some evidence that home prices are different in the Northeast as opposed to other areas. Not a huge amount of evidence, but there's some that something might be going on there. Because this p-value is greater than 0.05, the 95% confidence interval would probably contain 0. If the p-value was at 0.05, then that would be right on the interval. It's just over 0.05. It's 0.0569. So 0 will probably be in it, just be in the interval. So you can read the rest of that about how that works. You basically can compare the p-value to your alpha, the leftover from the confidence interval, and see kind of what's happening with that. All right, so we're going to do the other side of the equation now and see what happens when we do a confidence interval. We said the confidence interval would probably contain 0, but probably just barely contain it, because that's very close to being the 5 of the alpha, because we're at a 95% confidence level. So alpha is 0.05. All right, so we did a 95% confidence interval. We again used the difference in the two means, calculate our standard error, same one we had before. And here we find the t, which is 0.975, and we use 38. The smaller sample size was 39, and we come up with a margin of error of 138.7698. When we do our confidence interval, it comes out to be -273 and 4, so just barely above 0. 0 is included, but just barely, because that number is really close to that number. So just predicted, we're just inside that interval. It may be a little confusing, but that's kind of what you can compare. You can compare that number to the alpha value and see what's going on. All right, one more example. Based on this sampling, we want to know if men and women check their smartphones a different number of times per day. So different. But we're talking about a 90% interval. So when we get done, we're going to see zeros in the interval that'll tell us what's going on. So we have the two sample means, and we have the difference in those. Again, doesn't matter if it's positive or negative. We said -0.5. There's our standard error formula, and our t, because we're doing a 90% confidence interval, would be 0.95. Smaller sample size is n equals 25, which leads to that number in this formula. And then that gives us a margin of error of 2.793. And our confidence interval is -77930 and -2.2070. That means we are 90% confident that the true difference in the average number of phone checks between men and women is between these two negative numbers. 0 is not in this interval, they're both negative. And the way we wrote them makes us think that the females check their phones more than males. Usually you can look back to the original data and see that the original sample mean for the women was higher than the men, so that's typically what's going to show up in your in the end of your testing. Okay, we're going to do the other side of that coin. 0 is not an interval, so does that, because 0 is not an interval, that suggests there's a difference. We're going to do the hypothesis test to check it from the other side. So the original hypothesis was they're equal or they're not equal. Same standard error. Well, now we do the difference divided by the standard error. We get a -3. Again, because of the not equal sign here, that leads to a 2 there. And we go to the negative side because we're on the negative side. And when we double that up, smaller sample size was 25, so we go to 24 for DF. And we still get a very small number. So if the average number of times per day that men and women check their phones is the same, if the null is true, the probability of we're getting these results are more extreme is 0.0053. It's unlikely. So that p-value is less than 0.01. So there's very strong evidence that the average number of times per day that men and women check their phones is different. That verifies the results that we came up with in the confidence interval. When we're doing two sample proportions or two sample means, it's usually not necessary to do both types of inferences. We don't need to do confidence intervals and hypothesis testing. They will generally show us the same information. So usually one of those is enough, because we're not trying to pin down one parameter. We're just trying to see if there's a difference in those two parameters. And typically the hypothesis test and the confidence interval are going to give us the same information, and that's why we've gone back and forth about what one shows based on the other result. So you can not have to worry about doing both of them, but just you need to know how to do both of them in case you're asked whichever one to do.